All right, so today we're looking at solution concentrations and ways to express concentration. And there's various ways that we can do that. So actually, we already looked at molar concentration. We're going to look at the other types of concentrations that exist. So just to recap what we mean when we say concentration or when we say solution, we're referring to a solution is a solvent with at least one solute, right? So it's a mixture. So the concentration is really a relationship between the amount of solute, and that amount can be expressed in different ways, per quantity of solvent in the solution, right? So in general, concentration is solute over solution. So what we've looked at so far is expressing solute in the value of moles, and we've looked at expressing the solution in the volume of liters. So this is what we're looking at today that can be changed depending on what type of concentration you'd like to express. So, as I mentioned, there's many different ways. The first three kind of are lumped together. They're known as what are called percent concentrations. So we can refer to concentration as volume and volume percentage, mass or weight per volume percentage, so the W is like for weight and volume, or weight and weight or mass and mass, however you want to think of that percentage. Okay, so this usually kind of depends on what you're talking about. If you have a liquid dissolved in a liquid, volume and volume fits beautifully. If it's a metal alloy where you have a solid mixed with solids, sure, weight and weight, but not necessarily. You can measure the weight of a liquid also, right? So it just depends on what type you'd like to express. Parts per million and parts per billion are known as what are dilute concentrations. So meaning very, very, very small quantities of solute. So parts per million and parts per billion, we will get into that. And of course, molar concentration we've already done. So why do we have so many different ways of expressing concentration? So it depends on what you're working with. If you're in a chemistry lab, you're using moles per liter, okay, always. But not everyone knows what a mole is, or, they might have taken grade 11 chemistry like 20 years ago, so they may not remember what a mole is. So actually, percentage, most people can understand when we say something is 50% or 75% of a solute. So actually, percent concentrations you'll see a lot on things that you can purchase, like solutions that you can purchase maybe at the pharmacy or Canadian Tire or the grocery store. Those things that you can buy in like everyday person stores usually are expressed in percentage. So I'll give you an example. Vinegar. Vinegar is a solution. So vinegar is typically a 5% solution. So meaning 5% is actually the main component that makes up vinegar, and out of the whole volume of the container. So let's say you have a 1 liter container of vinegar. 5% of that 1 liter would be made up of the component that makes vinegar, which is actually acetic acid. So, we have all these different variations of concentration because it depends on what you're looking at. Now, parts per million and parts per billion, typically where you will see this is where you have very, very small concentrations of solute. So usually that's environmental science or health sciences. So for example, let's say we're doing water quality and we want to look at all the different components in water. Let's say tap water. So like tap water, if you want to know how much, how much chlorine is in there, chlorine ions, or what is the salt component, or let's say there's a pesticide in the water. The amount of items that are in the water are very, 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 very tiny, typically. So, for example, right, if you're dealing with blood samples, so if you're looking at, let's say, a toxin that's in a person's blood, or a person has cholesterol, they want to know the percentage of cholesterol in their blood. It's usually in very, very small quantities. It's not like you have, if you have large quantities of either of those things in the water or in your blood, not really great. But usually in the environmental or health industry is where you would find those terms, right? And of course, if you're just doing a chemical experiment or you're doing a laboratory, in any chemistry lab, you would have moles per liter, of course, because you know what a mole is. And we deal with it all the time. Okay, so we're going to look at each one of these. So percentage volume by volume concentration. So the units here are going to become incredibly important. So units are always important when we're looking at calculations in chemistry or any science, physics. It doesn't matter what you're looking at. You need to include your units, right? So percent volume per volume. So the numerator, remember the numerator is always the solute. The denominator is always the solution. The only thing that's changing is like, what is the solution expressed as? What is the solute expressed as? So in this case, when you're dealing with volume per volume percentage, your volume must be in milliliters. So this is milliliters for milliliters of solute, milliliters of solution. Okay, so for example, vinegar is labeled as 5% volume per volume solution of acetic acid. That means that for every 100 milliliters, right, 5 milliliters of acetic acid in every 1 milliliters of solution. If you were to calculate this out, that's 5% volume per volume. And when you write percent, by the way, notice how this has volume per volume beside it. You must include that. Remember, we just finished saying there's 3 different types of percent concentrations. You need to express what type this is. So when somebody's reading the concentration, they have to be able to understand what it means. Like, what's the meaning behind 5%? 5% of what? Right? So 5% volume per volume automatically translates into volumes, right? Okay, so let's look at an example. So a solution used in photography contains 140 milliliters of pure ethanol in a 500 milliliter bottle of solution. What is the volume by volume percentage of ethanol? So the volume of our solute is our ethanol, right? 140 milliliters. Our solution, so solution, I just use short form, so SOL''N for solution. We have 500 milliliters, right? So we want percent weight by volume. Pardon me, volume by volume. So the solute is always in the numerator. My solution is always in the denominator, times 100. So we have 140 divided by 500 times 100. So we get 28% volume per volume. Okay, so the units cancel. Again, when you're dealing with percentage is not really looked at for significant digits here. So I would just keep it as is. Do not round your answers. You want to try and be as accurate as possible, whenever possible anyway. Okay, so again, you have really 3 variables, right? You have percentage, you have your volume of your solute, volume of the solution. So you'll always have enough information. You'll have 2 out of the 3 things, right? Usually you're solving for one of these. So obviously, let's say you were solving for volume of the solute, they'd have to tell you the percent volume per volume, and that should kind of make sense at this point in time for you. Okay, so percent weight by volume. So again, this is where we're dealing with, it's always solute over solution. We have now mass over volume, right? Weight over volume. The units, mass must be in grams. Again, volume is milliliters. So anytime you're dealing with percentage, the mass has to be grams, the volume has to be milliliters. Okay, so if a hydrogen peroxide solution is 3% weight by volume, right? What does that mean? Well, for every 100 milliliters of solution, because it's a volume, we have 3 grams of hydrogen peroxide. Right? So this translates into being out of 100 typically. All right, so let's take a look. So what mass of copper 2 chloride is required to make 1 liter of 5.2% weight by volume of copper 2 chloride solution? Okay, so we're looking for mass or weight of copper 2 chloride. You can call this weight or mass. I'm just trying to be consistent with the percentage labeling here so that it makes sense for us. So the volume we have, and this the volume of the solution, is 1 liter. Okay, but you have to recognize, okay, we're dealing with percent, so that means that this has to be expressed in milliliters. So we have a percent weight by volume of 5.2%. So let's take a look at our formula. So percent weight by volume, we know is going to be the weight of the solute over the volume of the solution times 100. So again, we have 2 out of the 3 things here. So we have 5.2%. And then you can replace this with an X or whatever. You can keep it as that. But basically, we're trying to solve for the numerator in this case. And the volume of the solution is 1,000. Okay, so essentially, we are going to isolate for our numerator. So the first thing you want to do is get rid of this times 100. Right, so to get rid of a multiplication, you divide whatever you do to one side, you do to the other. So this becomes 0.052 is equal to X. It's no longer a percentage, right? X over milliliters. Okay, so then now we're dividing, pardon me, we're going to multiply the 2 to solve for X. So we have 0.052 times 1,000. So we get 52, and you have to recall that the unit here for percentage when dealing with mass is grams. Oh, actually, I didn't even look for sig figs. So now sig figs will matter, right? So 1.0 is 2 sig figs. We don't look at the 5.2, so actually this is already good. Okay, so 52 grams out of that 1,000 milliliters represents 5.2%. All right, so percentage weight by weight. So if you notice, all of these are kind of the same thing, right? As we're going through the percentages, it's solute over solution. It just depends on the unit. So if we're dealing with weight and weight, that means it's mass and mass. Both of them must be in units of grams. So an example here, brass, right? Brass is a metal mixture. So brass is a solution that contains 85% weight by weight of copper. So what does that mean for us? It tells us that for every 100 grams of brass, there's 85 grams of copper, right? That translates into 85%. So let's take a look. So we have benzoyl peroxide is an active ingredient in many acne creams. According to the product label, its concentration is 5% weight by weight. How much acne cream would contain 12.5 grams of the active ingredient? So we have here, let's talk about what we have. We're given percent, so we're given concentration. So the concentration is 5% weight by weight. Now we're looking for the acne cream. The acne cream is the solution. So even though it's, it might be like a liquid paste or whatever it is, but the benzoyl peroxide is the active ingredient. That's in the acne cream. So how much acne cream means we're looking for the weight of the solution here in this case. And we're told that there's 12.5 grams of the active ingredient, which means our solute weight is 12.5 grams. So our formula is going to be, right, percent weight by weight is equal to weight of the solute over the weight of the solution times 100. So we'll put in what we have. So it's 5% weight by weight is equal to 12.5 grams over X, or weight of the solution. You can keep the symbol if you'd like. So the first thing we're going to do, we divide by 100 to get rid of this. So we have 0.05, 12.5 grams over X. So essentially, it's kind of like you're doing cross multiplication, right? So these two are going to swap places. So X is going to be equal to 12.5 divided by 0.05. And I'll continue this in the next part.